Hi everyone, our project is US flights data analysis, visualization, and delay prediction. Team members are Yue Luo, Yuhao Cao, and Song Gao. Every day there are on average over 100,000 flights in the air all over the world. Huge number of people and cargoes are transported from place to place, facilitating the business communication of the world. With the huge amount of flight data, we can discover immense valuable information. For example, we can discover the airport's traffic in different time periods, which help business planning in the area. We can discover the most popular routes, which may help the travel agents for marketing. We can obtain the geographical information of airports and plans for most profitable cargo transport center, or we can predict delay and cancellation from historical data and minimize financial loss by carefully choosing the airline and date. In this project, by studying a large amount of flight data in US, we are planning to first do analytics on data, find out more valuable information and relationship between data. Second, make use of visualization tools, visually present the message and trends discovered from data. Third, build regression models for delay prediction, find out the most significant factor leading to it. To make an overview of the system, we use Python and SQL as main language, Pandas and BigQuery for data storage and preprocessing. We use package Matplotlib, Plotly, and Basemap for visualization. Scikit-learn is used for some machine learning algorithms such as k-means, linear regression, and random forest. We build web application using Django and D3.js on Google Cloud Platform. And offline analysis can be done in Colab.
So the first step of our project is to do some basic data analysis on the original data set. And our goal for this part is to find some statistics and valuable information from the data. And this part includes three topics. We want to understand each data set and their relationship, and also how to handle the missing data. We did some cancellation analysis by airline, departure airport, and weekday and month. And we also draw some data distribution plot to see like airline distribution, most frequent routines, flights by month, and weekdays. We basically use Colab as platform and Pandas for data processing and Plotly for data visualization. So let's first talk about our data set. So we are using the data set that can be downloaded from the Kaggle, which shows the flight data with delay and cancellation information in 2015 in United States. So there are basically three sets of data. First one is the airlines, which include 15 major airline operators in the United States, including Spirit, like Hawaii Airline. Second set is airports. It includes more than 300 airports in the United States, also with its geographical information, so that we can later on draw the map to show our analysis results. The third set is the flights data set. It includes more than 5 million flights in 2015 with the information such as date, airline, airports of that flight, all the delay and cancellation details. So let's first look at the airline dataset. It has only two features, the IATA code and the airline name. The second dataset is the airport, which has more features, but mainly the useful ones are airport names, the city and state where the airport is in, and also its geometric information. So this is a plot of airports by state. So we can see that Texas and California has the most airport counts. This is the graph of airports by city. So we can see mostly each city will have only one airport, but like San Diego or Chicago or Houston, they will have like both two airports. So here is the last data set, flight data set, which includes many features that we need to handle with. And here are some useful features that we will use in the future, like the airline feature. We can use it to join with our airline dataset, and also the origin airport or the destination airport to join with the airport dataset. So there are some terminologies that show up in the previous slide, and so we can let me explain some relationships between these terminologies. The taxi out is equal to wheels off deduct departure time. Taxi in is equal to arrival time deducts wheels on. Air time is equal to wheels on deduct wheels off. Elapsed time is equal to air time plus taxi in plus tax out. So here are some analyzed results, and here is the origin, arrival, airport distribution, and we can see that these two plots are basically the same. This is because flights are usually come and go, so that's quite reasonable. And this is the origin, arrival, city distribution. Here's the airline distribution, and we can see that the Southwest Airlines has the most count. Here is another format, the fan chart of the airline distribution. Here is the air routes distribution. Just like I said before, flights are also come and go. So you can see that the first route is from SFO to LAX, and the second count is from LAX back to SFO. So this basically because flights are come and go. This is the plot of air flights by month, and we can see that only the February has the lowest count. This is because February only have 28 days, and that may be the reason why there's less count than the other months. This is the flight by weekdays, and the Saturday has the least count. This may be because that people may usually don't choose Saturday as their flight. And we also calculate the airline speed, and here is the airline speed distribution, and we can see the United Airlines is the fastest, and the Hawaii Airlines is the lowest, slowest. We also did some cancellation analysis because we found out that there are many data in the original data set that the flights are canceled because of like weather or other reasons. And here is the canceled count by airline plot, and also the canceled rate by airline. Here is the cancellation by plot of cancellation by departure airport. Here is the cancellation by day of week plot. Here is the cancellation by month plot. And we also did some study of the flight cancellation reason. There are majorly 4 reasons: the airline, the weather, the national air system, or the security. And we can see from the graph that no matter which airline you are, weather is always the important factor that will affect the cancellation. And here is the plot of cancellation reasons by departure airport. Here is the plot of cancellation reasons by day of week. Here is the cancellation reasons by month.
The second part is map visualization. In the first half, we make offline visualization and provide useful information visually. Several topics could be included, such as heat map of the airports, most frequent routines, and flights under different conditions. We use package base map and do it on Google Colab. First is to create a basic US map. Base map provides helpful APIs to draw the region by restricting the longitude and latitude. It could also draw coastline, country boundary, state boundary, and county boundaries to include a more detailed depict of the region. The map also projects real longitude and latitude onto a correct pixel location of the figure, so we do not need to take care of the transformation ourselves. From the data frame, we extract longitude and latitude of airports and project them as location on map. Then we plot circle center at these points as the airport. We can see that those 300 airports locate quite evenly in all the states. Then we plot the airports by traffic. Airports on the map are sized by traffic. To obtain the traffic of a departure airport, we group the data by departure airport and count the number. Then we plot the circles described in the last step with size proportional to that count. We find out that the busiest airports are ORD, DEN, DEF, DFW, LAX, ATL, and JFK, etc. They are located in the big cities at east, west coast, or at the middle of the United States. This layout minimizes the cost of transfer and benefit people living in the big cities. States are also colored by traffic. Similarly, we count the traffic of states by getting the flights departing in that states. This requires to merge 2 tables to get the states of departure airports. We find out the busiest states are California and Texas, which are the states with largest population. Showing the routes of flights on the map, so we can clearly find out where the flights are going to and coming from. The routes are differently by color and shading based on count. The counts are calculated by grouping departure airport and arrival airport together, but the route here are undirected. Since both ways of a route can have almost the same count, we can see that the most frequent flights are between these busiest airports. Here are 10 most frequent routes. The most popular air route is in red between LAX and SFO. We then plot flight traffic by time. We plot the routes by putting them into time bins in order to make the problem easier. We define 4 time bins: late night from 0 a.m. to 6 a.m. Morning is from 6 a.m. to noon. Afternoon is from noon to 6 p.m. Evening is to 6 p.m. to midnight. And we define the route is in this bin if and only if this departure time and arrival time are both within the time boundary. After filtering, here is the situation in different time periods. We can clearly see that afternoon is the most busy period and busiest period, and late night is the least busy one. This gives advice to many government departures or companies so that they can set up the service schedule differently in order to minimize unnecessary loss. For example, airport bus should have a shorter gap in the afternoon and a much longer gap in the late night. We also refine the periods, and you can see the situation in different hours. They're changing in different hours. Particular flights by airlines reveals the operation planning in US, and we can detect their base in US. This is easily done by filtering the flights by airline companies. Hawaiian Airline is clearly based in the Hawaiian Island. Alaska Airlines is centered in Seattle. And Frontier Airlines clearly has an operational base in Denver and is service radius out of the DEN airport. American Eagle seems to have 2 bases in ORD and DFW. Given a departure airport, we can depict its outflow traffic and see where its flights going to. We can find the connection between 2 cities from those relationships and design more customized business plan for them. For example, SFO has a strong connection with LAX and airports near New York. JFK has a strong connection with LAX and SFO. Atlanta has connection with so many big airports, same as DFW in Dallas. Splitting the airport into clusters and find out the centrals could be useful since they may provide suggestions to set up cargo transfer centers in that region. Such transfer centers may reduce the cost of transportation in that region. For this question, K-means algorithm is the best strategy. The input to this algorithm is the longitude-latitude position of the airports. After running the algorithm by scikit-learn for almost 3,000 iterations, 10 centrals are presented in the map by red circles. K equals to 10 seems to be a good choice since the centrals are located in different regions of US and they're separated well. Here are the internal traffics. We can see clusters in the mainland US are more busier than those since they contain more airports. The busiest one seems to be the one lying in the West Coast. Between the centrals, we can also find that the communication between 2 clusters centered close to Atlanta and New York is much more frequent than that between the other 2 clusters. Second half of this visualization is a web application. A GCP VM instance hosts the Django service. Service query result from GCP BigQuery and sent to d3.js for form and visualization. It also has similar components as the offline ones. If we run the service one cluster, we can access it at this public location, but we are not running all the time to save money, so you can access it at the local address. So here is the web service for map visualization. The first component are staged. They are color based on their counts, and when we move mouse to it, it will pop up the information of it. This is easily done by querying the states and counts from the tables. And then, similar to the states, airports are represented by circles, which size is proportional to the count of this departure airport. It will also pop up the information of and also show the flights departing from it. The lines width are also proportional to the count of the flights in this year. It can be done by covering the departure airports and all destination airports with count. We make the result aesthetic, and with D3JS, it's easy to find the route by searching this key. Third part is flights by airlines. When we move mouse to an airline, on the right-hand side, we will see all the flights from these airlines. This is easily done by covering all the flights in airline company, and we can clearly see the base and the operational routines of this company. Finally, we set up time axis. We with the mouse going to some point of the axis, it will transform the position according to time. These files will be filtered, and those files with the time contains in its departure and the arrival interval will be shown. We query 2,000 files to reduce query amount, but this is still a bottleneck to be improved in the future. Design of this time axis can also be improved since we can only move it again and again. So moving on the axis will not change the visualization. Here are just some presentation slides for this.
The third part of our project is about the delay, and we focused on two parts: delay analysis and delay prediction. The first part is delay analysis. We try to understand the influence of different factors on delay, and it includes the delay analysis by factors and delay visualization on map. We use Google Colab as a platform and Pandas to process data and Plotly to visualize the data. And this is a result of the average delay by factors. And this is the average delay by departure airport. We can see some airports have a significantly large average delay like ILG and MVY. And this is a result of average delay by airline. We can see NK and UA has largest average delay. And for months and day of week, we can see June and Monday has significantly largest average delay. And for departure period, we can see that evening has the largest average delay and night has the smallest average delay. And then we try to visualize this delay on map, and this is an airport delay situation. And we can see ILG has the biggest circle, which represents the largest average delay in previous graphs. And this is the airport delay situation in different states. And we also visualize the flight routes delay, and these are all kinds of flight routes. And we also visualize the 10 most delay routes. And the next part is to predict the delay and make it online. And we try to predict the departure delay based on these factors and make the prediction on website to ingest new user data. We will first process the data and then build ML models to model departure delay. And we will deploy the delay prediction online for real-time user flight information. We train our model offline using Google Colab as a backend platform. And in the front end, we will try to parse the user data and use this trained model to predict the delay online. First, about the data processing, we have 5 features from previous analysis and 1 departure delay label. And we'll first try to delete and reformat our data. We'll remove marginal data and unknown airports, and also reformat the scheduled departure feature to a new feature departure period using this heuristic. And this is the data frame overview of our project, which consists of around 5 billion data. And then now we have 5 categorical features. We will use label encoder and one-hot encoder to encode these features. You can see month, weekday, airline, and departure period. We have more features corresponding to different feature level. But for a region airport, we have some problems because we have over 300 airports. The RAM will exceed even though we upgrade the RAM on Google Colab. And even though we have make it using a larger RAM on a GCP instance, but there are still too many features for regression. So our solution is to convert many airports to other label to reduce the feature level. And from our experiments, our best result is to convert the airport whose count are not in the first 100 and average delay are not in the first 100 and to other label. And we successfully reduce half of the airports. And then we build the regression model. After the data set split, we build a linear region random forest regression model. The MSE is around 160, and the large error percentage refers to the percentage of data whose predicted delay deviates from real delay over 15 minutes, and they are all around 12%. Considering the large data set and many features, we think these results are reasonable. And then we try to deploy the prediction functionality online, and we'll first parse a GET response in Django to get these 5 feature values. And in Google Colab, in the offline training, we will save the label encoder result to different documents and as well as the trained model. And in the front end, we will load these documents to match and transform these feature values to trained dataset format. And we will use the trained model to predict on these transformed feature values. And then we try to deploy the delay prediction online. And here is our web application. And we can see that we can insert our flight information like the airport, weekday, month, airline, and departure period. Let's say we have the evening. We should have the largest delay in our previous graph. And this is the result. And if we use a different period like night, we should have the smallest average delay in our previous graph. And we can see the different results. And this is our web application prediction functionality. And this is our presentation.